So this is a chi-squared test, and it's a two-way table, or a test of independence. We can see that because the hypothesis, they say independent and not independent, and therefore it's a test of dependence. It's also a two-way table that we have here. So for the first one, you're asked to find the value of k. So we know that these values all add up to 62, or that these values add up to 45. So you can use either of those options. So I'm going to use 34 plus k plus 22 equals 62. And then I can find the value of k, and k is then 6. And then for the second part, we're determining the number of degrees of freedom. So the degrees of freedom are the number of rows minus 1 multiplied by the number of columns minus 1. So the number of rows, we have 1, 2, 3, 4. So that would be 3 times, and then the number of columns, 3 minus 1 is 2. So the degrees of freedom there are 6. And then for the next question, you're asked to find the chi-squared statistic. So to do this, we're going to need to go to our GDC. We're doing second function matrix and edit. So our matrix needs to be 3 columns and 4 rows. So the opposite of what I've got. And we can now start to fill in the information. So 28, 34, 18, and 12. 8, and then our value of k that we found. Even if you got the value of k wrong, you could still pick up the marks for this part of the question, so long as you used your correct value, because the examiner will check whether it works with your value when they're plugging it through. Okay, so this is my matrix now stored. So now I can go into statistics and tests, and I'm looking for a chi-squared statistic. And the expected and the observed, we just leave as this. And when we calculate it, we have a chi-squared statistic of 18.1. So 18.1 for my chi-squared value to 3 significant figures. And then we need to state a conclusion for the test. So if we look at our chi-squared drawing, we're looking at a 5% significance level. So that means that this section here is 5%. And our p-value, if we look at our calculator, is 0.5%. So a much smaller area, 0.5%. And therefore it is in the alternative section. The other thing you can do is compare it to your critical value. It tells us our critical value is 12.6. So this is my critical value, and my chi-squared value is 18. So again, much higher up, 18.1, and therefore again we can use that. But either way, we're accepting the HA, the alternative, and we are rejecting the null hypothesis.